ping me at your convenient time. We can discuss. No problem.
Let's get started today. Today we can see on the list interface, we have linked list subclass. Linked list is a class which is a subclass to list interface. On the list stream, whatever classes are there, we are learning now. Yesterday we have seen the array list. Now today we can see the linked list. And the main important interview question is, what is the difference between array list and linked list? In real time, when to use array list and when to use the linked list, we have to learn after learning the what is linked list. So let's go to the programs. Now I created a different package for a linked list. com.wkr list linked list. Now there I have program2 class. Inside program2 I have a main method. Creating object to the linked list. And reference is a list type. So I have created a linked list as a array list. There. How to add the elements to the linked list? As we have seen till now, adding the elements to the array list, we have same functions to add the elements to the linked list. Now here we have add method, which will take argument of object type. We can add the object, any type of object. And we have add method which will take two arguments. First argument is the index. In which index you want to add, you can add the elements. We have seen the array list. Similar to that, we have linked list also, we can add the elements. Now let's go and run this. After adding what is the linked list elements, we have hello to all. Similarly, if you want to update the elements, yesterday we have whatever programs we have seen, today also same programs. I created object to the linked list. Only the difference is this one. Creating object to the linked list and referring with the list of strings. So whenever we are adding, I have just added the elements by calling the add methods and printing the elements. Initial linked list values are we are printing. After that, if you want to update the element, we have a linked list set method. Set of which index you want to set, you can set the values, we can run it. Let's go and run this. Initial linked list is this one. After updating the value, linked list is that one. Now next one is what we have to see is we have to learn how to remove the data from the linked list. To remove the data from the linked list, yesterday we have seen after adding, initial linked list is this one. I'm just removing the first index. Based on the index type, we can remove. Based on the object also, we can remove. So we are printing this. Now initial linked list is hello to all. After the first index removal, hello all. And second index in removal, we are removing the object directly. But object is a case sensitive. The string data is a hello. H is a small letter here, lowercase letter. But inside the data, we have uppercase letter. If you want to delete the hello, you have to give properly with the case sensitive. So if you run this, it will delete the data. You give the hello. Now we have seen how to add the elements, how to update the elements, how to remove the elements, how to read the elements. We have to iterate the loop and we have to read the elements. In program 5, I have main method. Inside main method, I have created object to the linked list. After creating object, adding the elements. Same program. Now to iterate the elements, we can use for loop, which will iterate from 0 to size, less than size. Then we are printing each and every element of linked list or get of 5. Same yesterday program. After that, I'm giving some space. Now, if you want to read the elements from each and every element of a linked list, you can use it by calling for each loop. This is a for each loop. For each loop will take right side. This is a list of the elements, and each and every element we are taking as a one value. That value we are assigning here. These both are very similar. To avoid all this, we can use only this one. String of ArrayList, linked list. Now this is a reading the elements. Let's go and run this. We're just reading the elements and printing this. Now, similarly, yesterday, similar to ArrayList. In the same program, I am just adding and removing and setting the elements. The same linked list, because the object is linked list. Here, if you see, whatever methods are there inside ArrayList, we have the same methods in the linked list also. If you want to create a class which is similar to linked list and ArrayList, you can create a class. If you want to create any common code to achieve linked list and ArrayList functionality, you can use common code, which that common code will take care of both ArrayList and linked list, because both are having the same methods. But earlier, before collection API, in vector and hash table, if you want to add the elements, we have add element method. In hash table, we have put element. But in adding the elements to the array, normal arrays means we have to add by using the arrays of 0, arrays of 1, something like that. So collection API is giving common methods to achieve all base operations, adding, updating, removing, and reading the elements. Now, what are the different methods we have in the linked list? Now let's go to the program. Inside the program, Control Shift F and go. Whatever unnecessary things are, do them. Now inside the program, now I created object with the linked list. The object type is linked list. So we can get the linked list extra features also here. Now adding the elements, I can add the elements directly by calling add method. These two add methods we have seen. Add of the data, add of first argument is a index, which index we are going to add, and second argument is a data. So in the linked list, we have two separate add methods. If you want to add the element at the first of the linked list, if you want to add the element starting of the linked list, you can add by calling the add first method. If you want to add the element at the ending of the linked list, you can add by calling the linked list.add last. These two are the extra methods which we get from the linked list. These two methods are not available in the ArrayList. But in linked list, we have these two methods to adding the elements at the first, adding the elements at the last. Now, after adding the elements at the first and last, first element is XYZ, last element is 1, 2, 3, 4. In between, we have the element of 1, 2, 3 and the ABC. If you print there, if you call this system.out.println, we will get output of first element is 1, 2, 3 and first index element is ABC. Now, if you print here, the values are 1, 2, 3 ABC. We are adding element at the first. So XYZ will come as a first element. XYZ 1, 2, 3 ABC. All the elements are shifting to next place. 1, 2, 3, 4 adding at the last. So it will go as a last. So we'll get the XYZ 1, 2, 3 ABC and then 1, 2, 3, 4. Now here, in case of arrays are normal arrays we are talking. Normal arrays, you can add similar kind of fixed constant. If you are adding the integer, we have to add all integers. If you are adding the string, we have to add all the strings into the arrays, because array is a fixed kind of data type. But in case of collection API frameworks, we can add any type of data type. You can add any objects. You can add any primitive types. Here I am adding linked list at add of 1, 2, 3. 1, 2, 3 is a primitive type. I can add. Here I am adding ABC string. I can add. Linked list at add first of string I am adding. If you want to add the object also, you can add. This is allowed in the collection framework. Any type of data, fix any kind of data type you can add. So if you want to read the elements of linked list, by default we have get of index. Get of 0 will be the first index. Get of 1, get of 2, get of 3. Similarly, if you want to get the first element, you can call linked list or get first. If you want to get the last element, we have get last. Similarly, for updating same function. Now just printing the elements at the end. So let's see. After adding the elements by using add first, add last, and base add methods, this is the linked list value. We are reading the elements, first element, last element, and index one element. Again, I'm printing the elements. Now, if you want to do for each loop, here we have for each loop of linked list. In object class, toString method is not overridden. So, just call the object class toString. What will happen? We'll see. Since it is a linked list collection framework, whenever we are getting object, we are getting the data. We can read the elements by using for each loop. This is a for each loop. From linked list, we are getting the each and every object and printing the object. Now, if I'm not calling toString method of this, what will happen? XYZ 1, 2, 3, ABC, POQR. Because inside linked list, whatever elements we are adding, this element is a string type. If we are adding string type, by default string inside a string toString method is overridden. So object class toString method is by default it is calling toString method of string class. If you want to add element of linked list dot add of I'm just adding new program. Now we'll get class name hexadecimal at the end because program is inside program class. ToString method is not overridden. But inside string class, this element is a string class type. So string class by default ToString method is overridden. So we'll get the data. Whichever class is not overridden ToString method, it will call by default object class ToString method because program class is extents of object. So we'll get class name at the hexadecimal. Class name at the hexadecimal. That we have covered in the object class. We have seen in the object class. By default, if you call any object, if ToString method is not overridden, we'll get the class name at the hexadecimal. If you want to get the data, because programmer want to see the data, not the memory address where the object is stored. So they have to override the ToString method on their own class. Now this is about the linked list new methods. We have some other new methods also, but as of now we can see these methods. Now the main thing, what is the difference between ArrayList and linked list? Now how linked list is working internally, that also we have to learn. Difference between ArrayList and linked list. First one, see ArrayList is created in collection API by using dynamic array. Array is created by using dynamic array. We have seen arrays. What is array? Now, similarly, inside ArrayList implementation, they used a dynamic array. Dynamic array means we can add any number of elements to the array list. So, the size of the array increase automatically. What is dynamic means? Size of the array increase automatically when you are going to add the elements. Linked list created by using double linked list. Linked list created by using double linked list. Double linked list already there in the collection API. Internally, while they implemented the linked list, they implemented it by using the double linked list. Now, how linked list is working? If you go to the linked list, inside linked list, each and every element we can call as a node. Each and every node is having reference to the next node, and it's having data. Inside linked list, whatever elements we are adding. Now I am adding linked list at add of 1, 2, 3. Now 1, 2, 3 having one reference. The reference is pointing to the next node. If there is no next node, the reference is pointing to the null, empty. So by default, inside each and every node, each and every data is having each and every data, we have the reference to the next node. That is called link to the next node. Internally inside linked list, we have nodes as a data. This is related to how they created the array list and linked list internally. That is the first difference. And second difference, maintaining the array list is difficult. Maintaining array list is difficult because adding or removing elements of array list if you add the element or removing the element of array list, we need to shift the elements which are next to adding index. Maintaining array list is difficult because adding, removing elements of array list, we need to shift the elements which are next to the adding index. You can take one example. Now inside my array list, I have 1, 2, 3, 4, 5, 6. Now I want to add element at index 5. So I want to add element at index 5 equal to 9 inside array list. Now first index is 1 is fine. Second index is 2 is fine. Third index is fine. Fourth index is fine. I want to add the element at the fourth index. So 0, 1, 2, 3. Fourth index I want to add the 9. So I will add the 9. After that, already it is having the 5. I want to shift all these elements to the next index. 5, 6. We have to do this much if you want to add the element. Similarly, I want to remove the element. Remove the element of first index. Now, if you want to remove the element of first index is 0th index is 1. First index is 2. I want to remove that. So, if you remove the 2, I removed it, but this one has to come to the first index. This one has to come to the second index, third index, fourth index, fifth index. So this is also, this maintenance is very difficult. If you have 1000 elements, all 1000 elements we have to move to the next stage or move to the previous stage. Next 9, 5, 6. This is called maintaining the array list is difficult because when we add the element in between of the array list, if you want to remove the element in between of the array list, whenever we are adding or removing, we have to shift all the elements to the right or left. In case of adding, we have to shift the elements to the right. In case of removing, we have to shift all elements to the left. 3, 4, 9, 5, 6 to the left. When we add the element, we have to shift all these elements to the right. After 9, shifting all elements to the right, 5, 6. So maintaining is difficult in case of array list. Similarly, maintaining linked list is easy. Because linked list is having node, linked list is having nodes which having data and reference to next node. Because linked list is having nodes, which node is a data and references to the next node. When you want to add the element, at index 5, so directly linked list, each and every data is having the reference. We can go to the reference of fourth index where you want to change the data. Directly you can go to the, if you have a reference, go to that reference, add the element immediately. No need to do from starting to ending, iterating the loop and adding the element and shifting the elements. Simply you can add the element by going to the index, by going to the reference. Since it is having the reference, we can add the elements and remove the elements is easy. Because linked list is having the nodes are having the data and reference. Since it has references, since it has references to the each node, we can add and remove elements easily. This is the main difference. Now, third difference. ArrayList is subclass of list interface, but linked list is subclass of list interface and DQ interface. We can see what is a DQ when we go to the DQ queues. Since it is having the subclass of list interface and DQ interface, it will get more features. Since ArrayList is only having the implements of list interface, it will get only list interface methods as implemented in ArrayList. That is the third difference. Now fourth one, when to use ArrayList and when to use linked list. This is one difference, and this is an important question also. And what is our difference between ArrayList and linked list also important for the interview. Now, when to use ArrayList and when to use the linked list. See, if you have a requirement of just add the elements to the list. After adding, simply read the elements of the list. You have requirement of adding and reading elements. You can use ArrayList. There is no manipulation. Manipulation means adding or removing the elements in between of the ArrayList. When to use linked list. You have requirement of manipulating the data of list. Means like adding or removing in middle of the linked list. If you have requirement of manipulating the data of list, you can use linked list. After creating linked list, if you want to change the values in between, you can use the linked list. After creating the linked list, if you want to changing means adding or removing in of a linked list elements, you can use the linked list. If you have requirement of creating an array list and adding or removing the elements in the array list, you should not use the array list. In that case, you have to use the linked list. These are the differences between array list and linked list. Now let's go and see some more points about the framework. Now, what is the hierarchy of the collection framework? See, all the collection classes and interfaces are from the java.util package. If you want to use the collection framework classes, we have to import java.util.arraylist. Just import java.util.linked-list. Without import, we can't use the collection framework classes and interface to the our class. Now, coming to the hierarchy. For every class, object class is a supermost class. Object class is supermost class. Now, in collection framework hierarchy, we have iterable interface, which we can learn in the next classes. Iterable interface is used for just iterating the data of a collection framework classes and interfaces. Reading the data of a collection framework classes and interface. If you go to any class, any interface, we have to read the data. So we have iterable interface is a supermost interface of collection framework. Now, after iterable, we have collection interface. collection interface is a supermost interface for the all collection interfaces and classes. From collection interface, no need, right? I have list interface, queue interface, set and sorted set, and map interfaces. These all are the list, queue, and set and sorted set. All these four are the sub interfaces of collection interface. And map interface is, it is a separate collection framework interface. It is not coming from the collection interface. It is directly sub interfaces of the iterable. But iterable is having two sub interfaces, collection interface and map interface. And collection interface is having some more sub interfaces. These are the sub interfaces of collection framework, collection interface. List interface, queue interface, set interface, and sorted set interface. This is a hierarchy of the collection framework classes, collection framework interfaces. From list interface, they have implemented ArrayList class, LinkedList class, and we have vector class. We have stack class. We have abstract list class. We have and so on, some two more classes are there. We'll see in the next classes all this. We have seen ArrayList and linked list till now. Remaining all we can see in the next class of list interface. Now I mentioned all the methods also. We can read all methods also, but most of the methods we won't use much, but that is fine. Now, till now we have seen only two classes of list interface. Let's see the other things in the next tomorrow class. We can meet in tomorrow class.